Hello and welcome to another tutorial. In this tutorial I'll be showing you how to make this grassy field using geometry nodes. The biggest benefit of using this method is that you can change the size and how hilly your land is at like any sort of time. You can do it in plenty of ways whilst keeping the grass and the flowers and other objects on top of the surface. So like the grass will stick to the ground as does the flowers. You can also add so much variety to your grass and flowers and whatever objects. You can make clumps of grass or clumps of flowers. You can spread them out fairly equally. And all of this can be changed super easily. Literally just moving sliders and stuff like that. The biggest drawback is going to be the performance hit to this method. Expect your viewport to be laggy and a bit unresponsive. There is a little trick that we can just get rid of all the lag, which I'll show you a bit later. Also, I would say that this is a beginners / intermediate tutorial. I try to make this as beginner friendly as possible. I will have my keylogger on the screen so that you know what I'm pressing. But if you do get a bit lost, check out my Blender Basics playlist where I show you the basics of navigation and modeling and texturing. Also, don't let the time of the video put you off. I have time-stamped everything so that you can come back when needed. I've also spent a lot of time explaining things in the video to try and help you guys understand what is going on and not just show you the method of making such a thing. With all that being said, let's get started. The first thing we are going to do is add a plane. This is going to be our ground. We are then going to go to the bottom tab and change the tab to the geometry node editor. We are then going to click new to make a new node tree. If we look below, we have two nodes that have popped up. The first one being the group input, which has one output named geometry. This node takes in data, which in this case is going to be the geometry of our plane. It takes this data to the node that it is linked to, which in this case is the group output. The group output node takes the data given to it, in this case the geometry of our plane, and then displays it. As we unplug the link between them, we can see this in action. Next, we are going to press Shift A to add a node called Set Position. We'll put this in between our nodes. We will then want to connect the geometry output into the geometry input of our new node. This is going to take the data of our plane and assign it a position, which we can manipulate by using these three values here. The first one being the x-axis, then the y, and then the z. Let's say we increase the z-axis. As you can see, the plane moves up. However, if we now hit tab on our keyboard, you can see two planes. One is our original plane and the other is the plane we have altered. This may be a little confusing, but the important thing about this is that you can see the difference between the two. One is affected by the geometry nodes and the other isn't. If we move a vertex of our shape that hasn't been affected by the geometry nodes, you can see that the plane affected by the geometry nodes is also changing. This is really cool as it allows us even more flexibility when designing our ground. I will demonstrate this later, but you will be able to hand change the shape and location of your ground and resize it in the way you like without being limited to the geometry tree. Next, we'll add the position node. Using Shift A, this is going to take the position or coordinates of our geometry and store them. If we don't have this node, we will not have enough sockets to rearrange the position of our plane if we need to. Next, we are going to add a subdivision mesh node. What this node does is act as a subdivision surface modifier. This is going to add vertices, which makes the mesh more detailed, allowing us to use a noise texture to create the shape of our ground. This node is also great because it is non-destructive and can be adjusted at any point. Make sure to have a high number on this. I'm going to have mine on 6. Next, we're going to add our noise texture. This will create the shape of our ground. As I'm only looking to manipulate the height of the ground in order to create an uneven surface, we'll only be manipulating the z-axis of our plane, as the z-axis is responsible for moving the plane up and down. This in turn will tell the noise texture to apply only to the z-axis of the plane. In order to do this, we will add a node called the combine XYZ. Connect the noise texture factor into the Z output of the combined XYZ node. Now we need to combine the manipulated Z axis and the current position of our plane. To do this, we need to add a vector math node. Connect the combine XYZ node into the bottom slot of the position node into the top slot. Then connect the vector math node output into the position node of the set position node. As you can see, the noise texture has changed the shape of our plane. If we look closely, we can see that the plane is now floating off the center of our world. We can get it back to the center by changing the offset value on the z-axis of the set position node to minus 0.5. The noise texture is a bit overpowering for what we want, so we're going to reduce the scale until we find a look that we like. I'm not able to get the look that I want. I know this as if I increase the scale value, it's too hilly. I can solve this by increasing the size of my plane, and this will disperse the effect over a bigger surface area. To do this, select your plane, hit S on your keyboard and move your mouse away from the object to increase its scale. You'll then need to press Ctrl A and select Apply to Scale. This will apply the new scale to our plane. If you don't do this, it won't change the effect of the noise texture. Continue scaling your plane and adjust your scale value on your noise texture until you find a look that you like. You can also play around with the detail settings and roughness. You can also change the dimensions from 3D to 4D. This will give you a W value, which when adjusted changes some values, I'm not quite sure. But basically, it allows you to keep the same sort of pattern and like variation in the height, sort of like a seed number. So if you're not quite happy with the look, you can play around with the seed and it will sort of give you the same sort of results, but it will look a little bit different. I don't really know how to explain it. I'm also going to right click my plane and click on Shade Smooth. This will make the plane look smoother. So we have finished our geo nodes for the ground. So the next thing we are going to do is give our ground a little bit of color and texture so it looks a little bit more like ground. So we're going to quickly create the basic material for the ground. Make sure you have the ground selected and we're going to change from our geometry tab to the shader tab. We'll then click material browser and click on the unused material. I'm going to name this material ground. First we'll add a texture coordinate and a mapping node. Change the type of the mapping node to texture. We'll then add a Voronoi texture to add some variation to our ground. Connect the mapping vector output into the texture vector input. Change the viewport to the viewport shading, which can be found in the top right, and then connect the distance of the texture into the material input named surface. This will allow us to see the pattern we are creating. We're going to use this to create a dirt-like pattern. I'm going to change the scale to 300. Next, we're going to add a color ramp. This will allow us to use multiple colors and change how much of each color will be used on this pattern. If we look at our color ramp, we have two little label looking things. We can click on one of them and below it is a colored box where you can change the color of the ground. You can also add more handles by clicking on the plus button, which will allow you to add more colors. Next, we are going to change the roughness. We're going to increase the value to reduce the amount of reflections. The ground is pretty crap, but we're going to cover it up with grass anyway, so I don't see any point in making it any more detailed than this. Now we're going to add our grass to our ground using the geometric nodes. Let's switch back to the geometric node tab. In order to get the grass to spread over our ground, we need a node to set points over the ground where we want our grass to be. The node will allow us to do this is called the distribute points on faces. We are going to connect the position of our ground into the points. This will place the points onto our ground. We will then change the distribution from random to Poisson disk. This is going to distribute the points randomly, but it will take into consideration the space in between the points. It will help us with reducing excessive clipping, and it will also help with giving a bit more of an even spread across the ground. Next, we are going to need to add our grass. So let's quickly model some. Whilst our plane is selected, we're going to click H to hide it. Then I'm going to use Shift A to add a plane. I'm going to rotate this on the x-axis by 90 degrees so that it is standing up. I'm just going to enter edit mode by hitting Tab whilst my plane is selected. I'm going to scale this down on the x-axis to make it thinner, and I'm going to scale it down on the z-axis to make it a bit more short. I'm going to tab back into object mode and move this up on the z-axis. I'm going to go back into edit mode and add two loop cuts by pressing Ctrl R, which will help us add some shape to our grass. Next, I'm going to move some of these vertices around to give the grass some shape. I'm also going to quickly make a material for the grass. I'll be doing the same thing as the ground but without the texture. If we adjust the color ramp, we're going to move the handles to see where our color is. As you can see, they are coming sideways, which we don't want as grass doesn't change color this way. We want it to come from either up or down the stalk. We can sort of do this quickly by changing the X rotation from 0 to minus 90 degrees. As you can see, this is better, but it's not perfect. Again, because the grass is going to be small, I wouldn't worry about making it perfect. Now I'm going to change the colors to what I want. Grass is typically greenest at the top of the stalk, and as it goes down, it gets a bit more yellow. Of course, the colour of the grass can vary a lot, and it will depend on stuff like the season. Next, we are going to add this grass to our ground. We can do this by using instances on points node. So let's use Alt-H on our keyboard to unhide our ground. I'm also going to quickly rename our objects. Give your object a double click to rename it. I'm also going to switch back to our Geometry Nodes tab and add to the node and plug it in between the Distribute Points node and the Group Output. Let's also plug the Set Position node back into the Group Output node. Next, we need to add an object for the Node2 instance. Once we have done this, it will display the object we want onto our points which are located on the ground. To add the information of our grass, we need a node called Object Info. We can use the eyedropper to select our grass and then plug the geometry output of our grass into the instance of our instances to points node. As you can see, nothing has happened. If we plug the instance into the group output node, it replaces the set position node. So what we need is a node that's going to combine our geometry of the ground and the grass and then plug it into the output node. To do this, we must add a join geometry node. As you can see, both of the ground and grass are there, and the grass has been placed on our points. I'm going to quickly move this single grass over, and if we look at our grass, you can see the grass is laying down on the ground. To solve this, we need to change the rotation of the grass. We can do this by rotating the points of our ground with a node called rotation Ulia? I think it's Ulia, not too sure. Connect the rotation of the distribute points into the rotation of the rotation Ulia node. Next, we are going to connect the rotation output of the rotation Ulia node and plug it into the rotation on the instances on the point node. We also need to change the rotation type from the object to local. This will keep the consistency of our grass's rotation. As you can see, by changing the X value in our rotation node, we can change the grass so that it's standing upright. As you can imagine, not all grass stands up the same. So we can add some more realism by adding a random value node. Change the value type to vector, as this will give us control over all the axes of the grass, as well as provide us with a range of values. This will prevent the grass from being at awkward angles. The minimum value is the minimum amount of rotation you want to occur, and the maximum is the maximum amount of rotation you want to occur. These rotation measurements, I believe, are done in pi, which can be converted to radians and degrees, but to make it simple, you'll need to input pi or 3.14 in order to get 180 degrees. It's probably best to just do this by eye instead of doing mathematical conversions. You can also adjust the other axes to add some variation to the look of your grass. Once you have got the values you want, we are going to solve the position of our grass. We are going to add a set position node and adjust the z-axis value until there is minimal clipping. I'm going to set it after the distribution points, as we can adjust the z-axis of these points and therefore the position of the grass. Connect the points to the geometry and then geometry to the points. I've set my z-axis to 0.1. Next we need more grass. To do this, we need to head to the distribute node and change the density factor to 1. This is going to give you the maximum amount of grass. You can also use the max and minimum ranges to prevent grass growing too close or too far away from each other. Have a play around and find the numbers you want. Depending on the size of your ground, the higher you may need to bump up the max number. For example, in my other project, I had my count on about 10,000. I also recommend muting the grass instant node because the chances are that your viewports will be pretty laggy now. To do this, just click on the object info in your node editor and click M on your keyboard to mute it. Once you want to see your grass again, just click on your node and click M again, and this will unmute that node. So I just want to quickly demonstrate that when I move the ground, the grass is going to move with it. As you can see, as I move it up and down, the grass stays with it. The last thing I want to show you guys is added some flowers, and we're going to do this through using modeling, and we're going to distribute our flowers through weight painting instead of directly from the distribute on points node. What you'll need to do is you can duplicate the nodes that we have just made, and we're going to model our flower. So I'm going to hide the ground and the grass, and then I'm going to add a cylinder. I'm going to scale the cylinder down a bit and extend it a little bit. I'm going to go into edit mode and move the top vertices up, and I'm going to extrude the top too. And I'm going to cancel this selection and scale those new vertices that we've just made outwards. Then I will extrude again and move it upwards. Next, I will press I to insert the face, and I will move this upwards. Next, I'm going to extrude the parts on the side to create the petals. I will go to the top view by clicking the punctuation key on my keyboard and click on top view. This will just make the extrusion easier. This will allow you to extrude the petals relatively straight from that viewpoint, instead of them being like up and down. Now let's add the subdivision modifier to our flower. As you can see, the subdivision has made some arches for us, and it will also add some detail to our model. It has left us with some problems, but to fix this, we're just going to add some loop cuts. If you're not sure why I am doing this, I have explained this in my modeling video, so check that out if you are interested. But basically, adding the loop cuts is going to shorten the distance that the modifier needs to do its calculations. I will also increase the modifier quality to 2. I'm also going to right click on the model and click on Shade Smooth. Next, we're going to add some color to our flower. So let's switch to the shader tab and make a new material. I'm going to call the name of the material flower stalk, and I'm going to change the base color to green. Next, I will make a new material and call it flower petals. I will then enter edit mode and change to face mode and select all the petals. I will then select the flower petal material and click assign. We will do the same with the flower head of our flower. I'm going to name the object to flower and apply all the transformations with Control A and then click on all transformations. I'm going to unhide the rest of the objects with Alt H. I'm going to connect the set position node to the distribute points on a faces node and the instances on point node to join geometry node. Next, I will go to object info and select our flower. Next, we are going to add a subdivision modifier to our ground. If we don't do this, our weight paint won't work. So I'm going to increase mine to 5 or 4, and I'm going to apply it. We will then enter weight painting mode. As you can see, our ground is now blue. This represents a value of 0, meaning no flowers will be added here. We also have the max value, which is 1, and it is colored red. By left clicking, you can start painting. You can change the value of your left click by adjusting the weight value. Once you have painted, you can go back to your GeoNode setup and change the density max to 1. We will then drag our density factor into the group input node. Next, we will go to the Object Data tab and change the name of our weight paint map. Next, go to your Modifier tab. Here you can see a new section has been added called Density Factor. Click on the icon next to the name to remove the currently linked density and replace it with the weight paint map. It will be called whatever you renamed it to. As you can see, our flowers aren't on the ground properly. To fix this, we need to set the origin of the flower back to the geometry. To do this, right click the flower and click on Set Origin, and then click on Origin to Geometry. The rotation of the flower is all messed up too, but we can adjust this in the random value node. If you aren't happy with the amount of flowers, you can change the density max. This will add more flowers where the areas are colored and according to the color of the weight paint. Also, if you're not happy with the size of your grass or the flowers, all you can do is select the object that you're not happy with the size with, scale it or change it in object mode, or you could do this in edit mode as well. Then once you have done that, you'll click Control A and you're going to apply all transformations or the transformations that you have made. Then you'll notice that the grass or flowers or whatever objects you have done this for will be all out of place. What you'll need to do in object mode is right click that object, then go to Set Origin and click on Origin to Geometry, and this will reset the location and position of that object. And there we go. You guys should now have a field that when the ground is being adjusted, the grass and the flowers move along with it. Of course, this gives you an insane amount of flexibility and control, and you can pretty much do whatever you want to your field. I hope you guys found this tutorial useful. I really try and explain everything the best I could, and I hope I gave you guys some understanding of how the geometry nodes work. Thank you for watching. If you get stuck, feel free to leave a comment in the comment section, and join my Discord if you want any help. Take care. See ya.